All right, here we go. 12.3, day number 1. Okay, today we're going to prove a couple of identities that are going to be critical to chapter 13, which we will see starting in a couple of days. Obviously, this is chapter 12. And then I want to talk about secant x, cosecant x, and cotangent x. I'm going to do that first. So we're familiar with sine x, cosine x, and tangent x. These three special functions, cosecant x, secant x, careful with that one, and cotangent x are brand spanking new to you. Okay, so sine x, we recall in a triangle, right? If this is our angle x, is opposite over hypotenuse, right? So opposite over hypotenuse. The cosecant is going to be the reciprocal of that, so it'd be a hypotenuse over opposite. And in turn, what that tells us is that the cosecant of x is the same as 1 over the sine of x. Okay, so it's reciprocals with that. So sine, what I like to think about is s turns into a c, and c turns into an s. Okay, so you'll see that in a moment. Cosine would be adjacent over hypotenuse. Oops, adjacent over hypotenuse. And therefore, the secant would be the hypotenuse over the adjacent. Therefore, the secant is 1 over cosine x. And as you can imagine and anticipate, cotangent will be 1 over the tangent of x. Now, x could be replaced with this symbol called theta, which you've seen a little bit before. But if we have opposite over adjacent here, we would have adjacent over opposite here. So let me give you an example of that. Let's say the sine of x equals, I don't know, 1/3. Well, then that means that the cosecant of x would be 3 over 1. Okay. If the cotangent of x is equal to, let's say, 2/3, what would the cosine of x equal? Now, it's not going to be 3/2. This is a funky one. Let me sketch this in the coordinate plane. Okay, here's my triangle. Cotangent, remember, is adjacent over opposite. So that means if this angle is x, adjacent is 2, opposite is 3. You may recognize that more formally, right, as tangent, which is 3 over 2. But how would I find the cosine? Well, the cosine would be 2 over whatever the hypotenuse is, right? Adjacent over hypotenuse. Well, how could I find the hypotenuse? Well, I'd use Pythagorean theorem. 2 squared plus 3 squared equals, we'll call it h squared. Okay, so that's 4 and 9, which is 13. So the square root of 13 equals h. So if the cotangent is 2/3, then the cosine is 2 over root 13. Okay, let's keep moving. I would love for you to take a stab at the unit circle all by yourself. Each of these right here, you can tell those are angle measures in degrees as you go around the circle. Okay, so those are your important degree measures. There's 2 of them here because it's 0 and 360. Right? Then you got your radians. Oh, I missed that one. Oh. So you got all your radians. You need to be able to convert for all of those. Oh, that'd be 0 and 2 pi. And then you've got your cosine, sine, 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 all the way around the circle. Your cosine is your x value, your sine is your y value. And you guys, if you know the first quadrant, you know all quadrants, right? This point right here would be square root of 3 over 2, comma 1/2. So this is my cosine and this is my sine. This one would be root 2 over 2. That's a 45, or pi over 4. That's root 2 over 2. That's my cosine and my sine. Right here, I would have 1/2 square root 3 over 2. Right here, I would have 0, comma 1. Okay, and down here, I forgot to do it, but this would be 1, comma 0. So the cosine of 0 equals 1. What is the sine of 0? Well, the sine of 0 equals 0. Sine of 0, where does 0 come from? The angle measure. This is your angle measure. This is your value that goes along with it, right? So the cosine of 0 is 1. Oh, yogis. Okay, so unit circle should be your friend. If you know this quadrant right here, you should be able to project that into any other quadrant. Just changing, right? We know over here positive, comma positive. So cosine is positive, sine is positive. Over here we'd have negative, positive. Down here we'd have negative, negative. Over here we'd have positive, negative. Your values are very important that you know these and whether or not they're positive or negative. And oh, look at those. Okay, so I don't have angle measures up there in degrees, but I could. That'd be 30, 45, that'd be 60, that'd be 90, that'd be 120, 135, 150, 180, and so on. That's 210, that's 225, that's 240, that's 270. 270 plus 30 is 300. This is 315, this is 330, and this is either 0 or 360. Bang, good. Unit circle, our friend. Important things about the unit circle, which we will talk about later, is the cosine function has a domain of all real numbers. Okay, I could rotate and my angle could be whatever I want it to be, but the range has to be between -1 or 1. Look at that. The max value here is +1. The min value here is -1. And it can equal either of those. Same thing is true for the sine. All right. And we're going to graph those a couple chapters from now. Okay, so here is the bulk of the lesson today. I want to form 3 identities. These are very important for chapter 13. This is something you're going to want to kind of put in the back of your mind. You won't be tested on it in this unit, but it's very important. So I take this triangle, okay, and if the hypotenuse here is 1, what I would know is that the x value along here would be cosine of theta. Right? We agree that the cosine of theta would be our x value over r, and in this case r is 1. Therefore x would equal cosine theta. Our y value here is sine theta. Okay, so we got this circle, or excuse me, this triangle, and it looks like that, right? We got cosine theta, sine theta, 1. Let's develop our first identity. Oh, this feels so good. If I used Pythagorean theorem, cosine squared theta plus sine squared theta equals 1. Identity number 1. We're a third of the way there, but actually not quite. It's going to take a lot more work to get there. Okay, let's look at another triangle. How about this one? Chow. 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 Okay, this is going to be kind of weird, and it might seem kind of weird, but I'm going to drag that thing out. Oh, dang it. Let me group that. Okay, so I'm going to take that triangle, and I'm going to pull it on out here. Oh, that was great. And that one too. And that one too. Okay, now something to think about. Remember, this length went from center of the circle to the edge of the circle. What would the length of that be? If you think 1, you are absolutely right on. Okay, now this length right here, I don't know the value of. I'm going to call that A. And this right here, I don't know the value of that. I'm going to call that B. Okay, now this is really cool. This angle is congruent to this angle. And also we have a 90 in both locations here. Therefore, this is theta. So rewind your mind a little bit back to geometry and recall this. Similar triangles have proportional sides if you have at least two congruent angles. So that side corresponds to that side in the same way that cosine corresponds to 1, in the same way that sine corresponds to b. So let's write out a proportion. Okay, so let's go in the triangle we know information about. So 1 cosine theta sine theta is proportional. Okay, let's do a little highlighting because children like highlighters. Okay, green. 1 is proportional to what? Cosine is proportional to what? And sine is proportional to what? Let's write in these missing values here and do some cross multiplication. Well, 1 corresponds to A in the same way that cosine corresponds to 1, in the same way that sine corresponds to B. Now what we can do, you guys, is we can cross multiply here. Let's do a little work on that. First thing I'm going to do is I'm going to cross multiply these two and figure out what A equals. So I get A times cosine theta equals 1. Cool. Divide by cosine on both sides. A equals 1 over cosine. So what is A equal to? Secant theta. Okay, so A here is equal to secant theta. All right, let's do another cross multiplication set here now. Instead of finding A, let's find B. All right, so that would be what? B cosine of theta equals sine of theta times 1. I'm going to divide both sides by cosine theta. My goal is to isolate B. So it looks like B equals sine theta over cosine theta, which means that B equals tangent of theta. Tangent of theta. There we go. So let me resketch this triangle over here in green. Here's theta. We said this was secant theta. This was 1. This was tangent theta. Oh, hello, Pythagoras. 1 squared plus tan squared equals secant squared theta. I'm going to rewrite in simpler terms. Basically just 1 squared equals 1. Identity number 2. Hello, friend. Okay, let's review. Identity number 1, we had cosine squared plus sine squared equals 1. Identity number 2, we had 1 plus tan squared equals secant squared. Let's go identity number 3. Okay, let me see if I can get rid of the green without, oh, I might as well just scratch it. Okay, let's sketch the final triangle. Let me toss this back up there. That's 1, that's sine theta. That's 90, that's cosine theta. The other one I'm going to do is this one. I'm going to sketch this and this. Ooh, poorly drawn. And that. Okay. Let me erase part of that there. There we go. Okay, which of the 3 sides do we know? Well, I know this side right here is 1. Sweet. I'm going to call this, I don't know. Let's call this C, and let's call this side D. Okay, now this angle is not equal to theta, but I do know that theta plus that angle equals 90. So I'm going to call that angle pi over 2 minus theta. So what would that make this angle right here? Oh yeah, you're right, you're right. I know you just said it to yourself. That angle would be theta. So let's sketch that down here. Here we go. This is really cool. I know, you're excited. That was theta. This is 90. This is 1. We called this C. We called this D. Our original triangle looked like this. This was cosine. This was sine. This was 1. This is theta. Okay, let's see what corresponds to what here. Let me get the old highlighter out. 1 obviously corresponds to the hypotenuse over here. I know some of you thought 1 corresponded to 1, but you're wrong. You're so wrong. The other angle next to theta is cosine. Oh, cosine corresponds to C, and therefore sine corresponds to 1. Okay, so let's write out our proportion here. Let me pick strategically. Okay, so I'm going to go C1D. Okay, let's highlight. Highlighter. C is green. D is yellow. And 1 is purple. Okay, so let's align those with those over here. Well, C corresponds to cosine because they're both green. 1 corresponds to sine because they're both purple. And 1 corresponds to D because they're both yellow. Now let's solve for C and D. Let's do C first. Boom shakalaka. C times sine theta equals cosine theta. Divide both sides by sine theta, and you get cosine theta over sine theta, which is your new function. Your new function is cotangent theta. Okay, cool. So C is cotangent theta. Let's do this one now. You might see it coming. Okay, 1 times 1 is 1, and D times sine is D sine theta. Divide both sides by sine theta. And it looks like D equals cosecant theta. Cosecant theta. So let's make a sketch of this triangle, and then we'll review our properties. This was 1. This is theta. D was cosecant theta. And C was cotangent theta. So by Pythagorean theorem, 1 squared plus cotan squared equals cosecant squared theta. Okay, let's put them all together, you guys, so we can see our 3 identities. Okay, let's cut and paste a little bit here. I'm going to move this down. There was identity 3. Let's get identity 2. Group that. Copy and paste it here. Uh-oh. Okay, I'll just leave it like that, even though it's going to bother me and you. I know it will. That's identity 2. And identity 1, I'm not scrolling all the way back up. I'll just rewrite it. Identity 1, just for symmetry's sake, cosine squared theta plus sine squared theta equals 1. Those are absolutely critical for next chapter, not this one. Okay, one more slide. Okay, so here we are. As you can see, secant equals 1 over cosine, cosecant equals 1 over sine, tan equals sine over cosine, and therefore cotangent equals cosine over sine. So if the secant were 5, what is the cosine? Pause the video if you want to take a moment. Otherwise, I'll tell you, it's 1/5. Okay, it's just the reciprocal. Okay, so let's see here. I want to skip ahead. Oh, no, never mind. Okay, so I see a problem like number 4. Cotangent of 4 pi over 3. What? Okay, so what I would do is I'd find the tangent of 4 pi over 3. And then once I get that value, I know that the cotangent of 4 pi over 3 equals 1 over whatever I got for the tangent of 4 pi over 3. So let's sketch that out in the unit circle and just see what it looks like. Okay, so 4 pi over 3, for some of you who don't know, here's pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. It's actually at 240 degrees. Okay, so if I back up here, let's go to the unit circle. Okay, 240, 4 pi over 3. I got those values. Remember that tangent of an angle is sine theta over cosine theta. Well, what is the sine? The sine is negative root 3 over 2. what is the cosine? The cosine is negative 1/2. Notice that these will negate each other, and the 2's will cancel. So I'll get square root of 3. The tangent of 4 pi over 3 is square root of 3. So if that's true, the tangent of 4 pi over 3 is the square root of 3, then the cotangent of that same angle will be the reciprocal of that. Okay, so at that point, I'd be okay with that. Some of you might like rationalizing the denominator. A varsity answer for that, if you rationalize, would be this. That is not required. Let's do one more example here. How about secant of negative 7 pi? Well, where would negative 7 pi happen? Here's 0 pi, 1, 2, oh, I'm sorry. Okay, how about this? 0, negative 1, negative 2, negative 3, negative 4. You're starting to see a pattern. Negative 5. Oh, all the odds show up on the left. Negative 6, negative 7. Okay, so what is that point? That's the point negative 1, 0. Okay, so when I see secant, I like cosine. What's the cosine of that? Well, the cosine of that will be the x value here, which is negative 1. So the secant of that same angle will be the reciprocal of negative 1, which is 1 over negative 1, which, go ahead and figure, is the same thing. So in this case, the secant and the cosine are the same. Okay, I want to do one more just because it's fun. I want to do number 29. Okay, I see that the cotangent is square root of 5 with theta in quadrant 3. So I'm going to sketch this. Cotangent, okay, the first thing that I do in this case is I say, okay, I don't have anything in the denominator, so I put it over 1. Now remember, a cotangent is adjacent over opposite. It's the reciprocal of tangent. So I'm going to sketch my triangle. It doesn't have to be perfectly accurate, it just has to be in the correct quadrant. Adjacent is root 5, and opposite is 1. Now hold on, this is in the third quadrant, so these should both be negative, right? How come that doesn't show up? Because when you take negative over negative, you get a positive. Now what I want to do, though, is I want to find the hypotenuse, because I need sine, and sine is opposite over hypotenuse. So the one thing I do know is that this will be negative 1 over something, and the cosine, which is adjacent over hypotenuse, will be negative root 5 over something. And you can be guaranteed here that your sine and cosine will be negative here because the hypotenuse is always positive. So if I took negative 1 and I squared it, and then I took square root of negative 5, or negative square root of 5, and I squared it, and I set that equal to h squared, I'd get negative 1 squared, which is 1, and I'd get negative root 5 squared, which is 5, and I'd get then that h equals the square root of 6. So it looks like I get that. Okay. These would be very, very acceptable answers. They'd be good. They'd get you 100%. If you wanted to do this, that's always acceptable as well. Likewise, this would be square root of 30 over 6. Make sure that negative comes along with it. Awesome, guys. That is 12.3, day number 1. Out.